In this video, I'm going to show you how to solve a system using the process of elimination. For elimination, you want both of your equations to be in standard form. So we're going to look at negative 4x minus 2x equals negative 12. That's in standard form. And we're going to stack them right underneath each other. Here I have 4x plus 8y equals negative 24. And what I'm going to do is I'm going to make this just a big addition problem. Okay? Now, our end goal should be an ordered pair. Okay? An x value and a y value. Remember, sometimes you could get no solution or infinitely many solutions. Notice in this problem that if I add up my x's, those are opposites. I have a negative 4x and a positive 4x. Well, they cancel each other out. If I add up my y's, I would get 6y, because remember, that's a negative 2y plus 8 gives you 6y. So in this particular problem, my x's eliminate. That's the name of the game. I'm left with a 6y. Over here, I have negative 12 plus negative 24. That's going to give me negative 36. Simple equation. Just need to divide both sides by 6. Y equals negative 6. So I've got my y value. Now I need my x value. So I go back and think about substitution. I'm going to substitute this negative 6 in for one of these equations. It doesn't matter which one. Let's say I pick this one. I've got 4x plus 8 times y. Well, I know what y is. Y is negative 6. So I'm going to plug in negative 6. And I'm going to solve for x. 8 times negative 6 gives me negative 48. So I've got 4x minus 48 equals negative 24. Keep solving the equation. Add 48 to both sides. 4x equals, that's negative 24 plus 48. So that'll give you a positive 24. Last step, divide by 4, and x gives you 6. So I've got my x value, and I've got my y value. I'm going to put my 6 right up in there. Remember that your ordered pair needs to have parentheses. So there's my solution. If I graphed it, that's where they would cross. I could also solve this by substitution, but notice I'm going to choose elimination because they're both in standard form. Both in standard form, which is ax plus by equals c. That's when you want to use elimination. Now I want to look at a problem that doesn't easily eliminate like the last one did. Let's say that I've got negative 7x plus y equals negative 19. And I've got negative 2x plus 3y equals negative 19 again. I'm going to create a big addition problem. If I added up my x's, negative 7x and negative 2x, they would not eliminate. That would give me negative 9x, and that's okay. If I add up my y's, they would not eliminate. 1y plus 3y would give me 4y's. Well, I need something to eliminate. Either my x's need to eliminate or my y's need to eliminate. So if they're not automatically eliminating like they did in the last problem, we're going to make them eliminate. I notice that right here If that top equation was maybe, I don't know, a negative 3y, they would easily eliminate. And that's what I want to do. So what I'm going to do is I'm going to multiply every single term in the first equation by negative 3. So negative 3 times negative 7 gives me a positive 21x. Negative 3 times y gives me a negative 3y. Negative 3 times negative 19 is going to give me a positive 57. Now, I'm not going to do anything to this second equation. I'm just going to bring it on over. Negative 2x plus 3y equals negative 19. Notice that my y's will eliminate now. They are opposites. One is a negative 3y, one is a positive 3y. So when you do multiplication to every single term, you're not changing the value. So I can go ahead and eliminate my y's. Add up your x's. 21 plus negative 2 will give me a positive 19x. 57, take away 19, gives me 38. Divide by 19 to figure out what x is. 38 divided by 19 gives you 2. X equals 2 here. So remember, we want that ordered pair. We want that x and y. So I've got my x. Sometimes you solve for x first. Sometimes you solve for y first. Doesn't matter. Just depends on what eliminates. Remember, in this problem, the y is eliminated, so I solved for x. So I'm going to plug that 2 or substitute that 2 into either one of these equations. Doesn't matter. I'm going to pick this one down here. Negative 2 times x plus 3 times y equals negative 19. So instead of the x, I'm plugging in the 2. Now I'm going to solve for y. Negative 2 times 2 gives you negative 4, plus 3y equals negative 19. So I'm solving the equation for y. Add 4 to both sides. 3y equals negative 19 plus 4. That gives you negative 15. Very last step is you want to divide by 3. So y equals negative 5. So now I have my y value right there. I could check it. I could plug both of those values in. Negative 7 times x plus y equals negative 19. So I'm plugging 2 in for x. I'm plugging negative 5 in for y. Negative 7 times 2 is negative 14. Negative 14, take away negative 5. Well, that's negative 19. That works. Try it for the second equation. Negative 2 times x plus 3 times y equals negative 19. 2 in for x, negative 5 in for y. Negative 2 times 2 gives you negative 4. 3 times negative 5 gives you negative 15 or minus 15. And again, that is negative 19. It works for both equations. So if it works for both equations, it is the solution to the system.